All right, we've got ourselves a really important problem here about Ferris wheels. You will see problems like this all over the place. Suppose you are riding a Ferris wheel. After every one is loaded, the wheel starts to turn and the ride lasts 180 seconds. Your height h in feet above the ground at any time t in seconds can be modeled by the equation h of t equals 85 sine pi over 20 times the quantity t minus 6 close plus 90. So we've got quite a few things going on here. We see a Ferris wheel that revolves around. At certain points, it's probably going to repeat the process. So if you're here, you're going to hit this spot several times over the course of 180 seconds. You start out a certain amount of feet above the ground. You peak out at a certain amount of feet above the ground. Lots of stuff going on here, and we're going to end it by doing two calculator problems. So let's begin with what is the period. You don't look at this and see the period right away. This guy right here is the frequency. So if you're given the frequency, which is the number multiplied to t, or in this case, the number multiplied to the quantity involving t, the period is going to be found by taking 2 pi and dividing that frequency. So 2 pi over 20. Right? In order to get rid of a lot of this stuff, we're going to multiply the top and the bottom by 20 over pi. Multiply the top and the bottom by 20 over pi. The reason why we do that is it gets rid of all of this. The pi's also cancel out, and you end up with 2 times 20, so the period is going to be 40. So the period is how long it takes to complete one full cycle, or in this case, one full spin around the Ferris wheel. So what does the period represent? Well, the period represents the fact that it takes 40 seconds to complete a cycle, or in this case, a revolution. Sounds a lot more barbaric than it needs to be. What is the frequency? Well, the frequency is just that number right there. Just that number right there, pi over 20. Now, what does that pi over 20 represent? Well, the pi over 20 represents that little bit of change every 40 seconds. That little bit of change. So we can view this as one of two ways. We could view this as the distance traveled along the arc, or the central angles change. So I'll do that. What does the frequency represent? The angle measure changed per second. Okay? So like this would be the central angle. It goes pi over 20, pi over 20, pi over 20, pi over 20, and it takes 40 of those. 40 pi over 20s gives you 2 pi, which means one full spin around the circle. 40 times pi over 20 is 2 pi, which tells you a full spin around the circle. And again, you can also say arc length measure or stuff like that. But you don't have R, although we could find it, but I'm not going to go that far. What is your maximum height? Well, let's get rid of this. Let's clean this up a little bit. What we do know is we know that 85 represents the amplitude, okay? And 90 represents the midline. So what's going to happen is you have a midline right here at 90. The amplitude is not the very tippy top to the very bottom. It's the distance from the midline to the tippy top and the distance from the midline to the very bottom. So since the amplitude is 85, that means we're going to have a maximum height somewhere here at 85 plus 90. And then we're going to have a minimum height at somewhere minus 85. So the maximum height is going to be 90 plus 85, which is 175 feet. And the minimum height is going to be 90 minus 85, which is going to be 5 feet. And then you can prove the fact that the amplitude is 85 simply by adding stuff to that stuff. I just kind of lost my train of thought. Forget it. How many circles will the Ferris wheel make during the ride? Well, if the whole ride is 180 seconds, right? And it takes what is it, 40 seconds per circle per revolution. Well, then 180 divided by 40 is going to be 4.5. So 4.5 circles. So if you start around here, you're not going to end here. You're going to end here at literally its opposite, which is going to be convenient for us to do H and I. Now, what I'm going to do for H and I, and I'm going to do this both in one problem so I could just kind of get it all out of the way, is I'm going to answer these in one. I'm going to type in that equation into a calculator, and it's asking us how high we are when the ride begins. So what that means is I take this equation and I find out what happens when t equals 0. Then I'm being asked how far off the ground are you when the ride stops. I care about when t equals 180. So I'm going to do both of these in the calculator at the same time. I'm going to type that guy in. I'm going to find out when t is 0, and I'm going to find out when t is 180, and I'll be right back, and we'll see what we get. All right, let's kill two birds with one stone. Make sure your mode is set to radians. It is. We're good. We're going to graph this in y equals, and we're just going to use it that way instead of plugging in normal numbers. 85 sine instead of well, we do have pi. Where is the pi button? Pi is that guy right there. Pi over 20, open parentheses. Instead of x, we're going to use t, or instead of t, we're going to use x, minus 6, close it, plus 90. Now, we're going to graph it. We're not going to get a whole lot. Okay, not going to help us at all. What we're going to do is we're going to go to Window, and we're going to change things to where we care about. We know that our x, which is our t, happens between 0, so we'll keep it at -10, 0, and 180, so we'll stretch it out to 200 just for funsies. We know that our y minimum, we found out that our minimum height was 5, so let's keep this at 0. And our maximum was like 175, so let's bump that up to 200 just for fun. Now when we hit graph, we see what we need to see. Okay, we care about two things. We care about what happens at 0, and we care about what happens at 180. So at 0, I can do this second calc value. You could have also gone to your table and gotten an answer right away, but I'm doing this way. And by doing it this way, I get 21.2335. So that'll round up to 21.234. That's when x is 0. I'll write that out in a minute. When x is, or t, same thing, is 180, we're going to do the same thing by going to second trace, type in 180 after hitting value, and that gets me 158.7664, so 158.766. So let's take those two values and plug them in or write them out in our thingamathing. So when t was 0, we ended up with 21.234, and that's how high we are off the ground. So, you know, we're somewhere right around here. We're obviously not the first person on the ride. We're somebody right around here when the ride begins. When the ride ends, we're literally at the opposite end here, which ended up being 158.766 feet. Okay, so there you have it. Pretty exciting stuff. The reason, by the way, another fun fact why these numbers make sense and why we are polar opposites, you add these two together, you get 180. And 180 is the distance from the maximum to the minimum, which is what I was trying to say over here, if my words could actually, you know, put their words together like just now. But this is a very important problem that you will see a lot over AP Precalc tests, practice tests, maybe the real test, we'll see. But yeah, it was fun.